Alright, so in this particular video, I'll show you how to find distance and displacement for problems that is just not moving straight left, right, or up or down. But here we have a person moving, in a circular path. So if you need to, pause, read, and then keep up. Okay. So essentially here is a person at position A. This person is going to go from A straight to B, and then from B make a right to C, and then from C go along this outside perimeter of this particular circle. All right, let's go ahead and do part A, B, and C on the slide. Part A asks you to find the displacement from A to B. Keep in mind as you practice, pay close attention to wording. Displacement is a vector quantity, so it has to have a magnitude and a direction. Excuse me. So in this case, to find the magnitude from A to B, all you have to do is really just draw a straight line from starting point to ending. So this person is just going to go from A to B. So that particular answer is super straightforward. Well, the magnitude is 10 meters here, and because it is a vector quantity, you have to include the direction, and the direction here would just be north, so I just shorthand it to N. Okay, so that's that. Part B asks you to find the total distance from A to B to C. Well, this is pretty straightforward. Total distance, just add up all the grounds covered. So here we go. From A to B, we already know that's 10, and then from B to C, it's an additional 10. So 10 plus 10 would just be 20. So the answer for part B is just 20 meters. And distance is a scalar quantity, so all you need to provide is just the magnitude. Okay. Part C asks you to calculate the total displacement from A to B to C. Well, here comes the word displacement again. Displacement, once again, is a vector quantity, so you have to provide a magnitude and a direction. So pay close attention to this part. This is usually where new folks kind of goof off. Okay. All right, from A to B to C, even though the particular problem says from A to B to C, if it asks you to find displacement, you can just bypass all the middlemen. In this case, B being the middleman. All I'm going to focus on is just point A and point C. All right, so I'm just going to draw a straight arrow from A to C. So the best way to find displacement for like a two-dimensional problem is to really just draw a straight arrow that connects starting point to ending point. Okay, and just find that length. So by doing a little math. All right, so here to find this particular length, I have a right triangle. This is 10 and that's 10. But to help you visualize, if you want, you can also do this. I drew a dashed line, that's 10, and that's also 10. Okay, because this matches the radius of the circle that's given. So you're given two sides of this particular right triangle. Because it is a right triangle, you can apply Pythagorean theorem to find the magnitude. So I don't know what this hypotenuse is. I don't know what the length of the hypotenuse is. So I can just do that really quick. A squared plus B squared is equal to C squared. Well, A is 10, B is 10. Square both those terms, add them together. 10 squared is 100, 10 squared is 100. 100 plus 100 is 200. And then really to find C, square root both sides. The square root of 200 is going to come out to be about 14.14 meters here. So the magnitude of this hypotenuse is 14.14 meters, but that's just the magnitude. Part C asks you to find displacement. I just found the magnitude. Now I need to find the direction. Okay, and this is, you have to pay attention here because the direction is not just north to east. You have to make sure you find the angle and be really specific in how the vector is oriented. Okay, so here, make sure theta that you're calculating touches the horizontal axis from the starting point. Okay, so point A is my starting point. Theta there touch this horizontal axis. Sometimes folks who are new might provide the wrong angle. Okay, well, to find that theta, I'm just going to go ahead and show you probably how to do this, that you can apply for all sorts of problems. But if you're awake and using common sense here, both of the legs for this right triangle are equal, so therefore the angle here we already know, or you should know, this 45 degrees. Okay, but if not, you can just plug and check. So here I'm just going to go ahead and apply tangent to theta. Why? Because we're given the opposite and the adjacent to start here. Really, if you want to, you can do cosine and sine because now you have the hypotenuse. But I'm just going to stick with the diagram that was originally given by using the information given to me. Okay. All right. To find theta, all you have to do is do inverse 10 on both sides. The opposite here being 10, the adjacent leg also being 10. And 10 over 10 is just 1. So if you punch in inverse 10 of 1 on your calculator, hopefully your calculator is in degree mode, you should get 45. If your calculator doesn't give you 45 degrees, then most likely you're in radian mode. So make sure you switch your calculator to degree mode for these types of problems. Okay. All right. Other than that, the proper way to express your final answer for part C is simply 14.14 meters and then 45 degrees. Now that we calculated theta, but you need to tell whoever's rating you or assessing you that it is 45 degrees northeast. Okay, it's not sufficient to just say 45 degrees. You need to specify 45 degrees northeast because this arrow is pointing right and up, which is in the northeast quadrant of the compass. All right. That's A, B, and C. Let's do D, E, F, and G here. Part D wants you to find the total distance from A to B to C to D. Pretty light work. All you have to do is find each of the length and add them up. We already know from A to B is 10, from B to C is another 10, and then from C to D is 1/4 of the circumference of a circle. Well, hopefully by now, if you're taking physics, you know the circumference of a circle is 2 pi r. If you don't, there it is. But what do you do with this now? Well, you need to find the length from C to D. Okay, from C to D is just 1/4, 1/4 of the circumference, as shown here in the diagram. Right, this is 1/4, that's 1/4, that's 1/4, and that's 1/4. Well, all you have to do is, in order to find the distance from C to D, you just multiply the circumference of the circle by 1/4 or divided by 4. It doesn't really matter how you do it. And if you plug in r being 10, because it's given in the diagram, the radius of the circle here being 10 meters, you should get a value of 15.71. Now keep in mind, 15.71 is not your answer, right? That's just the distance from C to D. So part D asks us to find from A to B to C, C to D. So it'd be 10 plus 10 plus 15.71, and so this is the answer for part D. So 10 plus 10 plus 15.71, and that will give you 35.71 meters, and that's it. Part E wants you to find the total displacement from A to B to C to D. So once again, if I see the word displacement, I'm just going to bypass, ignore all the middlemen. In this case, the middleman would be B and C. So I'm just going to start at A and end at D. So if you watch my diagram here, I'm just going to take everything else, clean up, and then I'm just going to focus A to D. I'm just going to draw an arrow or vector that points from A to D. So the magnitude would simply be 20 meters because that's the length of the diameter. Well, what's the direction? The direction in this case would be just straight up or north. Okay. All right. So the answer to E is just 20 meters north. It was, again, keep in mind, displacement vector, make sure you include direction. Let's do part F. F wants us to find the distance from B to C to D, right? B, C to D to E. Okay, well, we already know the distance from B to C, which is 10 meters. We already calculated the distance from C to D, right, which is 15.71, and therefore from D to E must be the same distance as it is from C to D, because this is a circle, so the distance for each of the quadrant along the perimeter should be the same. Other than that, this one's pretty light work, so if it's distance, just add up everything. So this would be 10 from B to C is 10, from C to D is 15.71, and then from D to E is an additional 15.71. So I'm just going to multiply this arc from C to D by 2, really, or again, you can add the two values. It doesn't really matter. But you should get the same answer. So I'm just going to say from B to C is 10 meters, and then I want to multiply the arc length that I found from C to D by 2, because there's two pieces now. All right, other than that, if you simplify this in your calculator, you should get 41.42 meters. Scalar, so I don't need to provide direction. Let's go ahead and crack out part E. Part E wants you to find the displacement from B, C, D to E. I'm gonna ignore C and D because those are my middlemen. So really, I'm just gonna start at point B and end at point E. So I'm just gonna draw a vector or an arrow that starts at B, and it needs to point to where it ends, which is point E. Right? In this case, the arrow points leftward. So therefore, well, what's the magnitude? The magnitude is 10 meters because that's the radius that's given. And then what's the direction? West. Why? Because it's pointing leftward. All right, so that is the answer for part G. So part G is simply 10 meters, comma, W for west. Or you can say leftward if you like. All right, I hope that helps. Stay nerdy, don't be whack.